Hi everyone. I thought that for this video, I'd give a proper introduction to give you all the opportunity to see what I look like in person before jumping straight into the content. I'm Carl Shepherd, the Data Jiu-Jitsu guy, and today I'm going to do a deeper dive into the Data Lakehouse, which follows on from my previous video where I gave a brief overview. This video is still aimed at anyone with an interest in data, and I'll aim to keep it simple, but I will be covering some more technical details. Now, without any more delay, let's jump straight into the content.
So the agenda for today, first of all, I'm going to go through very briefly what a data lakehouse actually is. I'll then take you through the data lakehouse technology, as well as some of the vendors and products. And then we'll get into the fun bit, which is the demo, and then finally a summary. So first of all, what is a data lakehouse? So a data lakehouse is a new open data management architecture that combines the flexibility, cost efficiency, and scale of data lakes with the data management and ACID transactions of data warehouses, enabling business intelligence and machine learning on all data. So as I discussed in the previous video, this is essentially all about combining the best of a data lake and a data warehouse and putting that into a single platform. And a good visual representation of that is the Databricks medallion structure. So on the left-hand side here, you've got all of your company's data, which will initially get ingested into the bronze zone, and then there'll be ETL jobs that will run to move that data into silver and into gold. And then finally, this is where you can start to do your BI and your ML, so your business intelligence or your machine learning. So the data lakehouse technology. So I think this diagram, which I've taken from a blog that AWS did around the data lakehouse, is actually quite good, and it's showing you the different layers that make up a data lakehouse. So we start from the bottom here. So first of all, you've got all of your data sources, and then you've got an ingestion layer. And this ingestion layer is all about getting your data into that bronze area, which will sit in your storage layer. So that's this bit here. You've then got a catalog layer. And what that catalog layer is that's all the metadata. And what that does then, it'll allow you to indicate like what, if there's a particular folder that you've got, you can say what table that relates to and things like that. And also control access to certain tables. Then you've got the processing layer, which I'll go through in a bit more detail on the next slide, which you can, in theory, split it up into two. But on this bit here, your processing would be all your ETL and ELT, which will be moving the data in the storage layer between bronze, silver, and gold. And then also you've got like your compute side of things, because your consumption layer needs to connect to some sort of processing power to be able to read the data from the storage layer. So your consumption layer, finally, that's where you can do all of like your interactive queries, your business intelligence, and your machine learning. So just give you an idea of some of the different technology that you can use at these different layers. The ingestion layer is a little bit of a tricky one because it really depends on the data source, and there's lots of different ways to ingest data. But you can still use some of like the ETL tools like Databricks, AWS Glue, Azure Synapse, Spark, or pipelines. The next layer is your storage layer, and this is the key area which stores all of your actual information, so all of your bronze, silver, and gold data. And the main ones are Amazon S3 and Azure Data Lake Storage. Then you've got your catalog layer, which is you've got Databricks Units Catalog, AWS Glue Data Catalog, and also the Azure Synapse Lake Database. As I mentioned, you've got the processing layer, which can be split up into two. So you've got your ETL or your ELT layer, and this is all about moving the data between the different areas on the storage layer. And here is what we discussed in the ingestion layer. So you've got like your Databricks jobs, pipelines, AWS Glue, Azure Synapse again, and then Amazon EMR or Spark. And Spark is something you might hear quite a bit of, but that's basically Spark's used in quite a lot of these different ETL platforms. And then you've got the compute processing layer. So this is things like Amazon Athena, your Databricks serverless SQL endpoints, your Databricks clusters, Azure Synapse, serverless SQL pools. And finally, you've got your consumption layer, and the consumption layer would connect to some of these compute clusters. So from the machine learning or data science point of view, you've got your Databricks ML, Amazon SageMaker or Azure ML. From the business intelligence point of view, you've got Microsoft Power BI, which is probably the most popular dashboarding tool at the moment. You've also got things like ThoughtSpot, Tableau, and Amazon QuickSight. And then on the interactive queries type of thing, so this is more around like ad hoc querying and things like that. You've got Amazon Athena, Databricks has its own SQL area, and then you've got like Azure Synapse SQL as well. So before we go into the demo, I wanted to briefly touch on Delta Lake again, and this is the technology that allows you to convert your files and folders into the equivalent of database tables. And this is what makes the Data Lakehouse possible. Without it, you still would require that two-tier approach that we talked about with your data lake and your data warehouse being separated. What Data Lake does is that there's lots of different benefits to it, but the main ones are the ACID transactions, which ensures the highest possible data reliability and integrity. It also allows time travel. Now, don't get too excited. We're not talking about time travel in the Back to the Future sense here, but what it does do is it allows you to travel back in time on the tables that you're looking at. So in theory, if you have some errors that get introduced into your pipeline, you can actually look at what the data was, say 2 days ago, and actually revert your table back to what it was then, and then reload your pipelines with the corrected data. So that's a really useful feature. And then finally, one of the most important ones is the ability to run merge statements, which is essentially updating and inserting data, which is actually very difficult to do on data that sits in a data lake, which is another reason why people still used the standard data warehouses. So now we're going to go into the demo. So with this demo, I've chosen to use Databricks. And for those of you that haven't heard of Databricks, I know I've mentioned it a couple of times here, but basically what it does is it provides you with a notebook environment for running all different types of data workloads on a Spark engine. And just a bit of trivia for you as well, Databricks was actually created by the creators of Spark. Databricks is very simple to use, and it allows you to write code in SQL, Python, Scala, or R. I've put SQL and Python in bold because I think those are the two most popular technologies that people tend to use, and data engineers and data scientists, or any people that are looking to get involved with data, learning SQL and Python is probably going to be the most beneficial ones to learn. So in this very simple demo, we'll be using it to demonstrate a data engineering pipeline where data gets processed between bronze, silver, and gold. And then finally, we'll show you how we can consume this data. In the demo, we'll just show screenshots rather than going to Databricks, just to keep things simple. And you can visit the Databricks website for more information, and there's lots of resources and tutorials. They've also got a really good YouTube channel as well. And if you'd like to sign up to the community edition of Databricks, which is what I'll be using, you can just go to the community website that I've put here. So first of all, I wanted to show you the storage layer that we're using. So we're storing our Data Lakehouse data in DBFS, which is a Databricks file system, and this is only suitable for testing purposes. You'd use you'd need to, in a production environment, you'd need to connect it to your own storage, which would likely be in Amazon S3 or Azure Data Lake storage. So with regards to the processing layer as well, Databricks provides you with clusters to process your data for your ETL or your ELT, and also for consumption via queries, so for your business intelligence and machine learning. What the Community Edition does, it provides you a really basic cluster, but in a production environment, you can choose different configurations for different workloads. And you can also start and stop clusters, and you only pay for what you use. So I've just given you a very brief screenshot here just to show you the databases that were set up. So we've set up a bronze, silver, and a gold database, and this is the cluster details that we've got over here. So Databricks, one of the good things about Databricks as well is that it provides you with data sets that you can use for testing and building prototypes and POCs. So what we've done for our what we're going to use as part of the demo, we've used a table that's already been created by Databricks called people 10 million, which is essentially just 10 million rows of random people. And we've added that to our bronze database, and we can start using the data from there. So first of all, we're going to talk about the bronze zone. So you can see a screenshot here, and we're just doing a very simple select star from the bronze .people 10 million table. As you can see here, we've got an ID, which is the primary key, and you've got just various details around the name, gender, the birth date, social security number, and salary, all very basic. And as we've talked about before, the bronze zone is basically just a replica of source and no transformations take place. Usually in this zone, we'd have some way of identifying new or changed records for incremental ETL or ELT. Now, what I mean by that is, something like a modified date column. And what that would enable us to do is identify only records that have changed since we last ran the pipeline, so we don't have to reload all 10 million rows each time. Now in this example, we don't have an A, but that's fine just because it's for testing purposes. So now what we can do is we can create a view over the top of our bronze data, and this will be used to load the data from the bronze zone to the silver zone. So this is the view that we've created here. And the silver zone is very similar to the bronze zone, but with what we're going to do is we're going to add a load date column and also remove the middle name because that's not useful for us. And what we've also done is we've limited the view to only bring through 1,000 records, just so that we can mirror the behavior of a typical incremental ETL. So here's the create view statement that I used. As you can see, we've not included the middle name, and we're just using the current timestamp for the load date. And this is what happens when we select the table. So you can see that we've no longer got the middle name there, and now we've got the load date as well. So once we've got the view, what we do is we can run a merge statement. And what the merge statement does is it updates and inserts records based on the view that we created. And in this example, what you can see is that we've only updated 1,000 records because there aren't any new records. So if you look, there's number of affected rows 1,000, and they're all updated rows because we've already, we're using data that's already there. There's nothing new that we added. And just worth pointing out as well that I ran the full merge statement to load the full 10 million records before we ran the below, just so that we had the full data in there. And then if we do a select star on the data in the silver database on the people table that we created, you can see that we've got similar data to what we had in the bronze, but we've got no middle name as we discussed, and we've also got the load date in there. So now what we can do is we can look at creating a view that can be used to load the data from silver to gold. Again, I've done the same thing where I've limited it to 1,000 records just to mirror the behavior of an incremental ETL. And what we're also doing is we're going to enhance the gold table further by including a new column for gender description. So if you look in the view here, you can see that we've got what's called a case statement, which is quite a simple way of based on logic of a column, and we can set up another column. So what we're saying here is if the gender is equal to M, then set this to male. If it's equal to F, then set it to female. If not, it's unknown, and that will be our gender description column. So you can see here the output. We've got the same data as what we had in the silver, but we've also now got a gender description column. Again, the merge statement is used to update and insert records based on the view that we created. And in this example, I've not used a view of 1,000 records unlimited. And as you can see, it's updated all 10 million rows. So if you look, the number of effective rows is 10 million, the number of updated rows is 10 million. And as you can see, I've actually selected another view, which is different to the one I've just shown you. And that would basically the same, but without the limit of 1,000 rows. And just to take you briefly through the merge statement, you basically specify what table you want to merge into. So what table would you like to update and insert records into? What source of data are you going to use? So we're going to use the data from Silver and the view that we created. We're going to join it on the primary key, which is the ID that we showed. And then if there is a match on these IDs, we'll just run these very simple update statements. And if there isn't a match, then we know that it's an insertion of a new record, and insert star will basically just insert all of the columns from this particular view that we set up. So here's the output from the gold.people table after we've run the merge statement. And as you can see, it's also got the gender description. And again, we've also set up a load day like we did previously. And one thing to point out here is that using the catalog layer that we talked about, you can use this to actually restrict access to sensitive information. So in this particular data set, we've got social security numbers and salaries, as well as names, which is all quite sensitive information. So it might be that you have a team of data analysts, but only some of them work on, say the people data that you've got access to. So you can restrict access to the rest of the team and they don't get any access to this data and only assign it to the people that actually need to see this level of information. I just wanted to very quickly show you as well, I mentioned Python earlier. This is basically the code for in Python, which is actually running exactly the same query as what we ran earlier, just to display all the data from the people table in the gold database. So now this next bit, we're talking about the consumption layer, and this is where we can do some interactive queries. So within the Databricks notebook environment itself, it gives you the ability to create your own interactive SQL queries, but then also create your own visualizations. So all we've done here is created a relatively simple query, which is looking at the average salary based on a function. So based on someone's birth date, we can actually calculate their age as it is of now, and we can also use the gender description. And what that allows us to do is to create this nice little graph, which is basically got your age across the bottom and then the salary average across the side. And then this is then split down by male and female. And what we can also do from a consumption layer point of view is we can actually build business intelligence dashboards and reports. And what I've done here is I've used Power BI and connected it to the gold table that we set up and just set up a very, very basic dashboard. This one at the bottom here, this average salary by age and gender description, is exactly the same as what I've just shown you, but this is in Power BI as opposed to it being in Databricks. So finally, just to summarize, I hope this very simple Data Lakehouse demonstration was useful for you to understand how data can progress through the medallion structure, and then finally, how you can consume that data using interactive queries or creating a dashboard in Power BI. The scripts that data engineers create in the real world will be a lot more complicated than what I demonstrated, but the underlying concepts for the building the ETL or ELT jobs remains the same. We use Databricks to build this demo, but as I mentioned when I talked through the technology, there are other products and vendors that can be used, and quite often organizations use a combination of products. Finally, thank you all very much for listening. If you've enjoyed this video, then please like and subscribe, and if you've got any questions or comments, then feel free to leave them below. Thank you very much.